All right, yes. Is this audible? Hello?
Yes, teacher.
Okay. So let's just quickly revise what we have done in our first class. We had started with electric charge. So electric charge, we had seen it as the intrinsic property of matter that gives rise to various phenomena like electric force, electric field, which we'll be studying. And SI unit of electric charge is coulomb, whereas the CGS unit is electrostatic coulomb. Then we know there are two types of charges, positive charge and negative charge. And the minimum charge possible on the electron or proton, this is 1.6 into 10 to the power minus 19 coulombs. Then we had also seen that protons are tightly bound because of the presence of nuclear forces, which are 100 times stronger than the electric forces. So that's why only transfer of electrons occur and not the transfer of protons. Then we had seen charging. Charging basically means transfer of electrons. A body that gains electron becomes negatively charged, and the body that loses electrons becomes positively charged body. So there are various methods of charging. We had started with the very first method, that was charging by friction. Then we have charging by conduction and charging by induction. So we had only started with charging by friction. Rishan's audio has not been connected. There must be technical issues then. Fine. So in charging by friction, we had seen that if two bodies are rubbed together, then electrons get transferred. The heat energy allows the electrons to get transferred. Okay, one thing that you have to decide, which one is lightly bounded and which one is strongly bounded. So the body in this, the way we had taken this example also, after rubbing case and before rubbing case. So whichever body is strongly bounded, electrons removal from that body becomes difficult. And it is easier to remove electrons from that body in which electrons are weakly bounded. So if you are given any case in which we'll do a question also right now, then you have to identify which one is positive, which one is negative. You can identify how both are bounded to each other. So from there you can identify the body that is weakly bounded will allow the electrons to move out. If the body allows the electrons to move out, the body will automatically become positively charged. And the body that receives electrons becomes negatively charged. And by convention, we had seen that glass rod is taken as positive, silk as negative, while wool as positive and plastic as negative. So right now, just note down this question at least. We'll discuss it. It says if an object made of substance A is made rub with an object of substance B, then A becomes positively charged and B becomes negatively charged. So from here you have to identify if A is becoming positively charged and B is becoming negatively charged. So which has electrons tightly bounded and which has electrons loosely bounded. If, however, an object made of substance A is rubbed against an object made of substance C, now a third substance has been introduced. Then when A and C, both of these are rubbed, we see A becomes negatively charged. So definitely C becomes positively charged. Now you have to see if A is positively charged, negatively charged, and C is positively charged. Then in which case electrons are strongly bounded, in which case electrons are weakly bounded. That will help you to identify that if B and C are rubbed together, which will be positive, which will be negative. So note down the question first, then we'll discuss. Just take 2 minutes, note it down, try it yourself, we'll discuss it. So Kulsum Khan, this is your first class.
Yes.
All right. And we have one more student, Shin. Who is this?
Yes, ma'am.
What's your name?
Sheen. It's Sheen.
Sheen. Okay, all right. It's Sheen. Fine. So Sheen and Kulsum, we started with electric field and charges, and in with this we have only discussed electric charge till now. So I have made the revision. If you were present right now, then I think some of the things must have got revised. So today we'll continue with methods of charging. Whoever is getting the sign of B and C as positive, negative, whichever is there, just write me in the chat box. I'll know then. What's your answer? So only Kulsum has answered till now. Let's discuss it then. Okay, Fatima has also answered. Okay, let's discuss it then. See, for all those who were not there, this question says that if object made of substance A is made rub with an object of substance B. This is made rub, this is rubbed. Made rubbed. A is rubbed with an object made of substance B. So you have an object A with you have an object B with you. Now we don't know what are the signs of it. So the question has already given us that A becomes, after rubbing, A becomes positively charged and B becomes negatively charged. So A becomes, correct. Sheen, your answer is right. This is the correct answer. So see, A becomes positively charged and B becomes negatively charged. So write me, all of you, if A is positively charged and B is negatively charged, so in which body the electrons are weakly bounded? From which electrons removal is easier? Yes, all of you respond. Only Fatima and Hamza have responded. Yes, Krishna, Kulsum. Yes. See, A will be weakly bounded. No, because A is positive. This means electrons must have transferred from A to B. That's why deficiency of electrons created positive charge in A and gaining of electrons created negative charge in B. So it means electrons have transferred from A to B. If electrons are able to transfer from A, this means electrons were weakly bounded over here. Here it is easier to remove electrons from A. So electrons are weakly bounded in comparison to B. So that's why electrons have transferred. Now the second part of the question, the data that it has provided. It says if, however, an object made of substance A, that same substance A, this is rubbed against an object made of substance C. We have a third substance now. So this A is the same A. We have a different substance C now. So it says A becomes negatively charged. Now A will be negatively charged. So if A is negatively charged, we have only two types of charges. This means C will definitely be positively charged. Now tell me, electrons have transferred from C to A. That's why deficiency of electrons created positive charge in C and gaining of electrons created negative charge in A. In which case now is the electrons removal easier?
C.
C, correct. Yes, Krishna. This will be in C is weakly bounded. That's why it allowed the electrons to transfer. So it means in this case, electrons got transferred from C to A, making C positive, making A negative. So this means electrons removal is easier to remove electrons. Means A, in case of A, this was weakly bounded than B. In case of C, C is weakly bounded than A. Now see the last part of the question. It says that B and C are rubbed together. Now what will be the sign? B and C are rubbed together. Now see, you cannot directly predict the sign. You cannot randomly write any sign, so the other one will be the opposite of it. You have to think which one is weakly bounded than other. You have to compare between two. So see in this manner, A's electrons in A, these are weakly bounded than B. And electrons in C are more weakly bounded than A. So if you compare B's electrons, these are strongly bounded. Then A's electrons are present. Then electrons are C are present. How do we concluded this data? Because in this case, electrons present in A were weaker than B. That's why electrons were able to transfer from A to B. In this case, second part, electrons were able to transfer from C. This means C electrons present in C, these are more weaker. These are weaker than A. So electron removal becomes easier from C. It means electrons are tightly bounded in B, weakly bounded in C. So if electrons are weakly bounded in C and strongly bounded in B, electrons transfer will occur from which? C to B or B to C?
C to B.
C to B. If electrons occur from C to B, deficiency electrons will move from C to B. So this means there will be less number of electrons. Deficiency of electrons creates what kind of charge?
Positive charge.
Positive charge. And this will gain electron and become negatively charged. So B is strongly bounded. That's why it has negative charge. And C is weakly bounded. That's why it becomes positive. So in many of the questions, if you are provided with this data, you have to analyze in this way only. Take two of them, whatever case is given, just identify which is positive, which is negative, and which one is strongly bounded and which one is weakly bounded. So the question will be in this form only. So all those who have not written it down, just note the solution. And if anyone wants to write the question as well, let me know. I'll scroll it up.
Teacher, I am done.
All right. So if you all are done, then we can move forward. If anybody is writing, can stop me. Otherwise, I'm moving ahead. Now, see, this was the first method, charging by friction, where two bodies were rubbed against each other, and the transfer of electrons occur. Now, see, we have the second method. As I've told you, there are three methods. So the second method is charging by conduction. So see, charging by conduction is also similar to charging by friction only. The difference comes that in conduction, we do not rub two bodies. Two bodies are not rubbed against each other. In case of charging by friction, both the bodies were rubbed against each other, were worked in against the frictional forces, caused the transfer of electrons. In this case, charging by conduction, if an uncharged body is kept in contact with the charged body, just a contact is made. The bodies aren't rubbed to each other. The simple mere contact is made between those two bodies. Then whatever electron transfer will occur, we say that has occurred due to charging by conduction. So I'll write it down only. When an uncharged body is placed in contact. This is the difference between charging by friction and charging by conduction. Here the body is placed in simple contact with,
So they touch each other, right?
yes, exactly. That's
Okay.
why. With a charged body, it gets charged due to the transfer of electrons. So electrons will only get transferred in all cases. It's just that the methods are different. One more thing, if you have two bodies which are completely identical means if you talk about, let's say, sphere, then the radii of both the spheres are equal. So if you have identical bodies, then the charge distribution will occur, means the charge transfer will occur. It will occur equally. I'll explain. Just a second. See, if both bodies, these are identical, then the charge gets divided equally. This means, for example, if I have this sphere and I have another sphere, and the radii of both the spheres are same, it means both the spheres are identical. And if I tell you that the charge in this first sphere is, let's say, 4e, and here the charge is 0. This is the uncharged conductor and this is the charged body. Now, if I just place both these bodies in contact with each other, so charge transfer will occur from one body to another. This process is known as conduction, where the contact is made between the two bodies. Now see how charge will get transferred, because these both bodies are identical. So see, if this was the first body, this was the second body. Now in case of conduction, both the bodies have been made in contact. Now transfer of electrons have occurred. How electron transferred occurred? Plus 4e, take out the mean value. This is dividing equally. You can simply directly even look at the value. If 4e is there and you have to divide it between two bodies, how much will each body receive?
Two
Two.
electrons.
2 electrons, correct. So what you can do, since this is a very small number, so you can easily calculate that 2e will be on the first sphere, 2e will be on the second sphere. Just in case if you have large numbers, so do one thing, take the first value, take the second value and take out their mean. This will be q1 dash, means after transfer. So 4e divided by 2 gives you 2e, means plus 2e here, as well as 4e plus 0 by 2 gives again 2e. So both the bodies have received 2e charge. This is, or let me give you one more example. Here you all will tell me what will be the charge distribution on each body, and the condition is same. Both the bodies I have taken, these are identical. Don't look in the figure what I've drawn. This is just freehand drawing. Otherwise, the condition is that both the spheres have the same radii and they have equal, they are identical to each other. So if I tell you this is plus 4e and Q2 is minus 8e. So now you have to consider this minus sign as well when you are including it in. So just first solve this. Tell me the way I have done the previous one. How, when both these spheres are made in contact with each other, what will be the charge received by, let's say this is A, this is B. Yes, Krishna, Hamza, Kulsum, all are correct. Others also, this is very easy, simple mathematics. You have plus 4e, you have minus 80. Consider the minus sign and take out the mean value, the way I have done it for the previous one. Heva is also right. It will be minus 2e only. See, if you take plus 4e minus 8e divided by 2. 4e minus 8e is what? This is minus 4e. Minus 4e divided by 2 becomes minus 2e. So here it will receive minus 2e and this will also receive minus 2e. So are you able to see, if both the bodies have identical, both the bodies are identical, then the charge distribution also becomes identical. Okay, before moving on to the question, I think you should write down the points, then we'll do a question on conduction and this will be over, charging by conduction. Just note it down. So all those who have written the above part, note this question. And this is very similar question to what we have done the examples. Two identical spheres A and B. These have charges plus 4E on A and minus 2E is the charge on B. A third uncharged sphere. Uncharged sphere means the charge is 0 on C. This is first made in contact with A. If it is made in contact with A, then you have to first see what is the charge distribution. Now, it is made in contact with B. So the charge distribution of C you have to identify, A you have to identify, and B, all this three. Just note down the question. Take 2 minutes. Whoever get the values A, B, C, write me. Let's discuss it now. So Krishna's answer is correct. See, you have first sphere, let's say this is A, this is C. Now what does it say? It says that two identical spheres, all the three are identical to each other. A has plus 4E and B will be having minus 2E. All right. It says a third identical and uncharged sphere means the charge on C is 0. Now, if A and C, both of these are made in contact with each other, means conduction will occur. So how do the electrons will get distributed? We have seen this example only. If 4E is present on A and C is present on 0. Hafza, you tell me. What will be the amount of electrons received on A and amount of electrons received on C? Yes, Hamza is right. Hafsa. Yes, Hafsa, answer. You there, Hafsa?
Yes, teacher.
Try it once, try it yourself. If 4E is here, 0 is here. Both of these are equal. So if you have 4E with you, you have to divide it between two things. How much each will receive? Yes, Fatima, right? Hafsa, you try. You think it in this way. You have 4E with you. You have to distribute 4E between two objects. How will you distribute? How will you give each one of them?
Divide by 2.
Divided by 2. Correct. So it will be how much?
2e.
2e. 2e on each. This was the answer only. 2e and 2e on each of them. So even if you have to calculate it, it will be in this manner. 4e in this, from here 0, from here divided by 2. Take out the mean value. So this will give you 2e. So 2e will be on A. Now this is after conduction. This will be A. This is C. This is 2e and this is 2e. Now C is has 2e amount of charge. Now this says then with B, it is made in contact with B. So C amount of charge on C. This is C and this is B. So C we have calculated, C has 2e charge. B is already given minus 2e. Kulsum, check it for C. Rest are correct. Just check it for C once. Now you have to calculate the final charge. The charge that you are telling me, this is before the conduction with B. You have to tell me the charge after this conduction has occurred. Yes, now it's correct. Now it's correct. Yes, Hiba. Hiba, you tell me, what will be the amount of charge in each of them?
Excuse me.
Yes?
Ma'am, I have to open my fast. So can I?
Yes. Go and open your rosa right now.
Thank you, ma'am.
Yes, Hiba.
0.
0. It will be 0. See, 2e minus 2e divided by 2. This is 0. And this is also 0. 2e minus 2e divided by 2. 0. So ultimately, what are the charges left now? A had 2e. A was 4e. Now A had 2e. B became neutral. C also became neutral. Just note it down, those who have not written. So by now you all must have written it down. Okay, let's start with the last method that is left, charging by induction. So this is the last method in charging by induction. So we have seen charging by friction. The one we have done just now was charging by conduction. Now we'll start with charging by induction. Now see what is meant by charging by induction. See, if I have a conductor with me, let's say this is a conductor. It has certain positive charges in it. It will also be having negative charges. So Hamza Shekhani, you tell me, if amount of positive charge is equal to amount of negative charge, so is the body positively charged or negatively charged?
It's not charged, it's equal.
It's neutral. Neutral is the term for it. Yes, correct. So see, if number of positive charge is equal to number of negative charges, this makes the body as neutral. So we have over here, this is an example only. If I say these are positive charges, which is static. Why? We know, because positive charges are held by nuclear forces, so they will not move. These are the negative charges, which are mobile. These will move. Now see what is meant by induction. When a charged body, this is placed in a contact with a neutral object. Like if I bring up a glass rod, I have brought up a glass rod near it. This was the neutral state of the body. Now see, I have brought a glass rod. So there must be some charges residing on glass rod. So let's say this is the body. These were the charges present. Now a glass rod has been introduced. And the charge that the glass rod is containing, let's say this is positive. Glass rod has positive charge. Now tell me, all of you, if the glass rod is positively charged, so what kind of charges will get attracted by the glass rod? What kind of charges?
Negative charge.
Negative charge. Positive will attract negative charge. So as a result, what happened? All the negative charges will slowly keep on accumulating towards this end where the glass rod is present. So it will be in this kind. If this was the conductor, the positive charges will be left at one place. Why? Because the negative charges, these are getting attracted by the presence of the glass rod. If the glass rod is positively charged. So what has happened? All the negative charges which were present have accumulated towards the end, which is present near the glass rod. Now, if I reverse the case, had we not taken positive charge, had it been negative charge on the glass rod, then opposite will happen. All the positive charges would have accumulated near the glass rod and the negative charges would have resided away. So see, this phenomena of segregation of these two charges, whenever the neutral body, now it has been charged. One side it was negative, now it has become negatively charged from one end and positively charged from other end. See, overall the body is neutral. That's why induction is also known as temporary electrification, because this is temporary. As soon as I remove the glass rod, what will happen? Charges will redistribute among themselves and again it will become neutral. So induction is basically this temporary electrification. One end has now become negatively charged and the other end has now become positively charged, which was not the case previously. Initially, all the charges were equal and placed together. So this combination of positive negative charges, these were balancing each other and making the body neutral. Now, because of presence of any charge, this is known as the inducing charge. So now, because of presence of inducing charge, charges have been induced. So this part, this will become your induced charge. Charged, induced. This is your induced charge. Now this is your inducing charge. We'll also see a question how permanent electrification can be done through this only. But this phenomena of induction, this is known as the temporary electrification. This is temporary electrification. Why temporary? Because you all know, as soon as I'll remove this glass, there won't be anything to attract these negative charges and hold them. Right now, all the positive charges present on the glass rod is holding them. That will get removed. That's why we say this is temporary electrification. So this is the phenomena of induction. Let me write down the definition. In charging by induction, when a charged body, this is placed near a neutral conductor, it induces charges due to redistribution of electrons. This is what is known as charging by induction. So this will get clear through a question we'll do, how to do permanent electrification. Because questions in this manner from NCERT are also given through this only, charging by induction, these are also given, where you are provided any body and you are asked to, through the charging of induction method, you have to charge the body as positive or negative, whatever is the condition of the question. So that we'll do. Till then, just note down these points of charging by induction. Then we'll do a question. And if you have doubts, you can ask me in between. Zaid, again, you have joined late. Is there some issue because of Ramzan? Rosa playing?
No, ma'am. It's because I just came from this school.
Okay.
Yeah.
All right. So I think these timings are just because of Ramzan only. After the Ramzan, timings will get changed. So you
Yes.
will have the classes later on. Fine. So just watch the recording after the class. Take the link from sir and see whatever part you have missed. And if
Okay.
you have doubts, you can ask me. I think you all have must written till now. If anybody is writing, can stop me. Otherwise, I'm moving forward. Okay, before we move on to the question, one thing that is used in the questions of induction is the phenomena of earthing. Because without earthing, you cannot permanently charge anybody. Because whenever you will remove the inducing charge, the induced charge will be redistributed among themselves, again making them back to neutral. So see what is meant by earthing. All right. See, whenever a body is connected to earth, one thing becomes zero. When a body, this is connected to earth, its potential becomes zero. So we represent this potential through this sign. V becomes zero. This V becomes zero. So what is potential? We have a full separate chapter on electrostatic potential and capacitance in the coming next chapter. Regarding here, you have to just remember whenever a body is earthed, means a body is connected to earth, made in contact, connected through a wire by any means. Whenever a body is made in contact with earth, then what happens? Charge becomes zero. If it is set free, its charge becomes zero if it is free. If the charge is free as in all the negative charges, all the charges that are mobile charges will be able to transfer. So you have to remember, if V becomes zero, then Q becomes zero. So you don't know what is V, but you know what is Q. You are studying Q. So you should remember, whenever a body is connected to earth, potential will be zero. So as a result of which charge will be zero. Now see, you have to see in which body, from where electrons will transfer. Like if I tell you I have a positively charged body with me. I have a positively charged body, through some wire or any means I have connected this body to earth. I have grounded it. So electrons will definitely transfer. Electrons will transfer from earth to the body. From earth to the body. So positively charged body, from earth through the body, the electrons get transferred. This is transfer of electrons. Just contrary to it, if you have a negatively charged body and if you connect it to the earth, then the electrons will flow from the body to the earth. This is what is meant by the phenomena of earthing. Earthing means simply connecting to a body. Like human beings, human beings are good conductor of electricity. So whenever we stand on earth, we are connected to earth. What happens? Even if electrons pass through our body and we are not wearing any insulators on our foot, what happens? Electrons do get transferred to the earth. So that is only earthing. Earthing means the transfer of electrons from any object to earth. But electrons can transfer from earth through body if the body is positively charged, because from positively charged body, electrons won't move. Positive charges are already lacking electrons. So that's why electrons will flow from earth through the body in case of positively charged body, and in case of negatively charged body, electrons flow from body to earth. Now using this concept, how does the question on induction come? If I give you an example, see, I have a sphere. I have made the sphere stand on this insulating stand. This is a sphere. This is an insulating stand. insulating stand so as to not allow electrons or all the charges to move into the earth back, so that earthing does not occur. So if the question says, this is a part of your NCERT examples only, make this isolated sphere as positively charged. This is the question. Make this sphere as positively charged sphere. Now, using the method of induction, we can make this body as positively charged. See, if I take this sphere, this is the insulating stand on which the sphere is residing. Now it is neutral, means all the positive charges are equal to the negative charges. If I bring up a rod, now I have to decide whether the rod should be positive or negative. See, if I earth this means if I connect this sphere to the earth, then electrons transfer will occur. Electrons transfer will occur and the positive charges will reside. This is our method. This is our plan how to make this sphere as positively charged. For making this sphere as positively charged, what we can do, we can simply first segregate the charges and all the negative charges can go into earth. So what will we be left with? We'll be left with only the positive charge. So you have to identify which side it should be. Let's say if I take positive charge, I have taken positive charge. So Fatima, you tell me, if I take in positive charge, what kind of charges will be accumulated over this end? Yes, Fatima? If this is the inducing rod that I have supposedly taken positive charges. Then what kind of charges will get accumulated at this end?
Negative.
Negative charges. Negative charges will come. Means positive charges will occur over here. And if I earth this now, if I do the phenomena of earthing, what will happen if I connect it to the earth? This is the symbol of earthing. All the electrons will come into this. So is this a positively charged sphere? Did we require this? Did we want this to happen?
No.
Means we cannot take this charge as positive. This is not the right way to answer this. Let's just reverse it. Instead of taking positive charge, now let's take up negative charge on the inducing rod. So inducing, this is inducing charge. If I have taken the inducing charge as negative, what all charges will be accumulated at this end?
Positive charges.
Positive charges. And the other end will have negative charge. Now see, if the other end has negative charge, while keeping the rod only, keeping the glass rod at its place, this was positive, I have earthed it. We have earthed it. Earthed it means this is the symbol to represent that we have connected it through the ground, to the ground, and this is earthing. Earthing has been done. So all the negative charges, these will move into the earth. Now see, once you remove this and you are holding the glass rod still, positive charges are there, negative charges on this rod. This is the sphere that you have. Now, even if you remove the glass rod, what will happen? There are no negative charges present to balance or make the body neutral. All the negative charges we have eliminated through the process of earthing. Now, what are we left with? We are only left with positive charges. So the positive charges will get redistributed among themselves. So did we want this to happen? We required this only, positively charged, right? So now the sphere is positively charged sphere. So this is how induction method is used for charging. So just note it down. From earthing, I think you have written it till induction. Yeah. Done, all of you? Now see, before moving on to a very important law, we have to know few properties of the charges. So under this topic only, electric charges, we have to know the properties of charge. So the very first property is the additive nature of charge. Additive nature of charge. This simply means all the charges can be added, which you have already done, how to calculate a charge. For example, if this is a sphere or this is a body, this is plus 2 coulomb, this is plus 3 coulomb, this is minus 2 coulomb, it has minus 1 coulomb, and randomly I have taken some charges present on this. Now, if it has this much charge and I ask you to calculate the net charge present on this system, whatever is the total charge present on the system. So what you will do, you will simply do your simple algebra, mathematical algebra you will apply, and this net charge will become 2 coulomb plus 3 coulomb minus 2 coulomb minus 1 coulomb. So this becomes 2 coulomb only. So charges allow themselves to add algebraically, because there are many quantities which cannot be added algebraically. Like electric charge is a scalar quantity, so that's why it had allowed us to add itself. Had we taken force, electric force, when we'll reach on to electric force, we'll see we are not able to identify directly add it. We'll be using parallelograms law and all the vector additions. So additive nature of charge means that all the charges can be simply added. So net charge on the body, this is the simple algebra. Whatever is the total charges present on the body, you can add it directly, and that will be the net charge on the body. So net charge on body, this is the algebraic sum of the individual charges. One more property of charge is there. This means charges can be added. This is charges can be added. One thing is that charges are conservative. Means, have you read this statement of for energy? Energy can neither be created nor be destroyed. Similar is valid. Yes, exactly. So similar is valid for the charges present. If you have charges with you, charges are conservative. This is the second property. Charges are also conservative. Means conservation of charge. Simple, the way you used to do conservation of energy. This is conservation of charge. This means charge can neither be created nor be destroyed. Why? Because if I say a body is positively charged, it doesn't mean that it has destroyed the negative charges present in it. What happens? Transfer of electrons occur. So it can transfer from one body to another. From one body to another, charges can transfer. You cannot say that if a body is negatively charged body, this means that the body is having excess of electrons, that is due to creation of some electrons. Electrons have just transferred from one body, so net charge will be the same only. It's just the distribution of electrons or the whatever charges, mobile charges have occurred. The third property is invariance of charge. Invariance of charge simply means that charge does not depend on speed. Charge does not depend on the speed. Means if a body depend on speed, if I say there's a body, this is moving with, this body has 4 coulombs, this is moving with, let's say 3 meters per second. Now after some time what happens, the same body, the velocity has become 5 meters per second. So it doesn't matter that the velocity has increased by 2 units. It means the charge should also become 6 coulombs. Charge will remain the same. Means this simply means this is independent of speed. Is it clear till here? Are these 3 basic properties clear? Then we have 4th property, which is very important. So if you have any doubts
Yes,
till here, just ask me. All right. See, these are the basic properties. From here, only theory part comes. You have one more property, that is quantization of charge, and this is the most important property. But before that, see what we have studied. Charges can be added algebraically. Charges are conservative, means conservation of charges occur. Charge doesn't get destroyed or created by itself. And we have also seen that it is independent of speed. Quantization of charge means what? See, if I have Q1 with me as plus minus E. So yes, who is going to tell me? Krishna, you tell me, what is the electronic charge present? What is the value of this E in terms of coulomb?
1.6 into 10 power negative 19.
10 to the power
10 to the power negative 19.
minus 19.
Yeah, minus 19.
Okay, this is Q1 present. This is for 1 electron I have taken. Now I take 2 electrons. Let's say I have taken not electrons or any charge. Let's say plus minus 2E. I have taken 2. If I have 1, I have this much amount of charge. Now I have taken 2. So what will it be? Simply it will be 2 times into 1.6 into 10 to the power minus 19. Do you all agree?
Yes, teacher.
yes, ma'am.
So it means this is 3.2 into 10 to the power minus 19 coulomb. So I'm not considering the sign right now. If it is a positive charge, just add plus, and if it is a negative charge like electron, just add negative. All right. So if I have 2 charges with me, 2 electrons if I take or 2 protons if I take. This is the value I get. All right. Now, if I take 3 electrons with me, 3 charges with me, it will be simply 3 into 1.6 into 10 to the power minus 19. That becomes 4.8 plus minus 4.8 into 10 to the power minus 19 coulomb. Means 3 electrons are present till now. For 1 it was I have taken, for 2 I have taken, now for 3 I have taken. Let's take one more till here. Let's write. I have taken 4e with me, separate 4e. So net charge will be what? 4 times the charge present on a single one. That is 4 into 1.6 into 10 to the power minus 19. This becomes 6.4 into 10 to the power minus 19 coulombs. Do you all agree till here? This will be only the possible charge possible if I take these n number of electrons.
Yes, ma'am.
Yes.
So tell me, is there any number possible between 1.6 and 3.2? Is there any amount of charge possible between 1.6 into 10 to the power minus 19 and 3.2 into 10 to the power minus 19?
No, ma'am.
No.
It's not possible. For minimum, for one charge we have seen. For 2 charge kept together we have seen. Now half a charge you cannot take charges in fraction or in integers. Means if you have a complete charge, that this is the minimum value. If you have another charge, this is the minimum value only. So this property of charges, that it is becoming in integral multiple of it. See, if I write this as n, 1, 2, 3, what I am taking as n, where n means 1, 2, 3 and so on. How it is coming? N multiplied by E plus minus. In this manner only we are getting the charge. For n as 1 we can write, for n as 2 we can write. N means number of charges. Number of charges. So this means that all observable charges, these are integral multiple of 1.6 into 10 to the power minus 19 only. No charge other than 1.6 into 10 to the power minus 19's integral is possible. Whatever number you take, you ultimately have to multiply it with 1.6 into 10 to the power minus 19. That's what we have seen. When I had taken plus 4, there also I had to multiply 4 with 1.6 into 10 to the power minus 19. So all the observable charges, these are integral charges in nature. These are integral multiple of electronic charge. Electronic charge means integral multiple of 1.6 into 10 to the power minus 19 coulombs. If I tell you that I have a body with me which has plus 4 unit charge, negative charges are outside, net charge becomes what? Plus 4e minus 4e, this becomes 0. The body is neutral. If, however, I have to add some charges to this body, let's say this had 4 charges, the same body. What will I do? What is the minimum number of amount of electron possible to add into it? 1. Below 1, nothing is possible. More than 1 will be what? Next number 2, then 3. Only in this manner I'll be able to add electrons. Is there any way possible apart from this to add electron?
No, ma'am.
This is
No.
not possible. So that is what is meant by quantization of charge. Quantization of charge means all the integral multiple will be in terms of 1.6 into 10 to the power minus 19. Why? Because this is the minimum electronic charge possible. All right, is this clear?
Yes.
Yes, ma'am.
So note these properties of charges, and also let me tell you, from quantization of charges you have numericals from NCERT also, and questions do come in exam. So we'll also do questions on it in the next class. First you note down these. Just tell me once you are done.
I'm done.
I'm done.
All right, so I think most of you must have written it down. So I'm stopping till here. Revise quantization of charge and come. We'll begin from here only. All right, so you can leave the meeting. We'll meet on Tuesday now.
Thank you, teacher.
Thank you, ma'am.
Thank you, ma'am.
Okay.
Thank you. Thank you, teacher.